Okay, hello and good afternoon, everybody, or good morning, everybody, because now we have people in different time zones. And welcome to the 7th session of Sunoikisis's Digital Classics Summer Semester 2019. Today, I'm very happy because we have a very young researcher in classics presenting her work. And our guest today is Katie Felkner from the University of Oklahoma. And Katie is an undergraduate research assistant for the Digital Latin Library project. Katie attended our institute last summer at Tufts University at the Perseus project, where we had an NEH institute about digital editions, digital scholarly editions, and this institute was part also of our Sunoikisis's activities, and Katie had the possibility to join us at Tufts and to present also her work. And Katie has a Bachelor of Science in Computer Science and a Bachelor of Arts in Letters, and Katie, you can correct me if I'm wrong. So Katie has these both backgrounds in computer science and in the humanities. And she's working on this wonderful project, the Digital Latin Library, which is now an important project for new editions, critical editions of Latin text, open editions. So this is part of our work on Open Greek and Latin data. And today she will present a session entitled Servius, an object-oriented approach. As usual, you have the class outline on GitHub, and Katie wrote this outline where you have a list of the topics for today and also a few readings. So Katie, welcome to Sunoikisis's and thank you for contributing to our program. You have to unmute yourself, Katie, because I can't. Okay, excellent.
Hi, everyone. As Dr. Berti said, I'm Katie, and I am at the University of Oklahoma, and I'm going to be talking to you about my work in writing a script that automatically creates digital editions of ancient texts. So let's get started. All right. So I'm going to start off, going to go kind of like broad to narrow. I'm going to give an overview of my project and the Digital Latin Library, and then I'll drill down into some of the particulars of encoding Servius in XML. So the goal of the project I've been working on for about the last year is to automatically encode a digital critical edition of books 9 through 12 of Servius in XML. Specifically, we're encoding the Harvard Servius, the Merja Castor edition of those books. And we say that the finished product should be compliant with both the TEI and the Library of Digital Latin Texts encoding guidelines. And I will talk more about those in a minute. So just a quick refresher, what XML and TEI are. XML is extensible markup language. It's a hierarchical, so basically a tree-shaped database that can be used to encode a variety of documents. It's called extensible because users can define their own tags, attributes, and syntax rules. So like what tags can go inside what other tags. So I put this in here just as an example. Lem is the tag. Wit here is an attribute. All of this is the value of that attribute. And then in between the opening tag and the ending tag, you've got the text of that element, which could optionally contain more tags. So TEI stands for Text Encoding Initiative. The TEI consortium provides customizable and extensible guidelines for encoding almost any kind of literary or historical text. TEI and its various derivatives have become the de facto standard for encoding scholarly editions in digital classics. Okay, so the Digital Latin Library is the project that I work for. It's funded by the Mellon Foundation and hosted at the University of Oklahoma. I put in the reading, I put a link to some of the about the project pages if you want to learn more about like how DLL got started and the full breadth of what it does. So it's got two projects, the DLL catalog, which is basically cataloging existing digital editions that are out there, and then the Library of Digital Latin Texts, which publishes new scholarly editions of texts. The goal is to publish peer-reviewed digital critical editions of Latin texts encoded in XML according to the LDLT guidelines, which are a derivative of the TEI guidelines. I forgot to link those in the GitHub page, but I'll go back and edit it and add it after the session. Okay, so can you guys like hear me okay so far? Are we good?
Yes, it's perfect. We can hear you and we
Okay,
can see your
awesome.
slides. Yes.
Okay, then I'll keep going. Okay, so before we get into Python and automation scripts, we're just going to talk a little bit about who Servius is, what the text looks like, and how we encode it in XML. So, who was Servius? He was a 4th century grammarian and literary commentator. He's most famous for writing complete commentaries on all of Virgil's work, including the Aeneid. His commentary on Virgil was then really heavily edited and rearranged and expanded by a 10th century scholar, whom we now call Servius Auctus. So really what you have isn't just one text, it's two parallel texts that sometimes share text and sometimes don't. And sometimes one will have something the other does not. And sometimes the other has something the first one doesn't. So it's really two parallel texts. And what you've got on the right side of the screen here is the stemma. So basically a diagram of one editor's hypothesized transmission history. This stemma is only for the Servius half of the tradition. And you can see it's pretty complicated. You've got a lot of manuscripts out there, a fair amount of contamination across branches of the tradition. The Servius Auctus half of the tradition is similarly complicated. And ultimately, the takeaway here is that this text has a really, really complicated transmission history, even by classical Latin standards. So, how do we encode that? Well, historically, representing Servius in print has been difficult. On the left here, we have a traditional printed critical edition of Caesar's Bellum Alexandrinum. This is a fairly standard Latin text. You've got the main text up here, the critical apparatus down here, and fairly minimal formatting and markup. So you've got your paragraph numbers, you've got your sentence numbers there. And then you have a little bit of editorial markup, like your this editorial edition there. So let's contrast that to Servius on the right side of the screen over here. You can see you've got these vertical bars here, and you've got split text, some over here and some over here. This side is Auctus. This side is Servius. But that's not standard. That's specific to the Harvard APA Servius. And it's different in every edition of Servius. And the only way to figure it out is really to go read the preface. You'll also notice that in a real edition, all of the text that refers to the same text doesn't even fit on one page. So I had to sort of Frankenstein the slide together. I think that probably says something about how difficult it is to represent Servius in print, but I'm not sure exactly what that something is. So let's talk about more sort of the structure of the text and the encoding process. We want to go from here to here. That is from a traditional printed critical edition to this XML representation. And what we have to capture are these sort of typographical conventions that have a lot of meaning that isn't necessarily inherent in the character. And what I mean by that is these pipe characters, and whether or not there is text all the way across the page, encode what I call the type of a section of text. So it can be Servius, meaning Servius has it and Auctus does not. It can be Auctus, meaning Auctus has it and Servius does not. It can be parallel, meaning they both have text there, but it's not the same text. Or it can be same, meaning they both have text and it's substantially the same. What we've got here, so this first line is a same section. Both of them have it and it's pretty much the same. The second line is parallel. So you've got your Auctus over here and your Servius over here. This third line, it looks like it's just Auctus, but it's actually part of the parallel section. And we'll come back to this in a minute. And then this last section here, that's your, that's just same text. So looking at it in the XML, for a same section, you have a seg source equals sigma here means Servius, and then ds is Servius Danielis, which is another name for Servius Auctus. So that means both. Then when we have a parallel section like this, we get a choice, one seg from Servius Auctus and one seg from Servius. And then for this last section that's both of them the same, we just have that Servius and Auctus again. So now we're going to talk more about the structure of the text and how we encode that into XML. So here in the light green box, that's what I call a verse. It's the smallest numbered subdivision, and it is all of the text that refers to one line of Virgil. In the darker green box here is what I call a lemma. It is all of the text that refers to a word or set of words from Virgil. In this context, lemma does not have the same meaning as it does in the critical apparatus. It's just some words from Virgil. And this can contain several different segs. And finally, in the blue box, we have a seg. This is the smallest meaningful subdivision of text. It is a bit of text from one source, and the seg goes from, or a bit of text of one type, and then every time the type changes, we get a new seg. So that's kind of the overall structure of the Servius text. Going back to this line 547, and we'll cover this in more detail when we get to the automated encoding. But yeah, this here, what's in the blue box right here, is going to end up being one choice tag with a Servius Danielis section and a Servius Auctus. Excuse me, a Servius section and a Servius Auctus section. Okay. So that was kind of a fair amount of stuff. Does anybody have any questions right now?
I don't know if we have questions in the audience. I hope everything is clear, because we have not only classicists in our audience, but also computer scientists. So maybe we can very briefly go back to the text to summarize the structure of Sergius' work as a sort of summary for people not.
Okay, I will screen share again.
Thank you very much, Katie. Okay.
Yeah, so Dr. Berti asked me to go over the structure of the text one more time.
Yeah.
And basically there are three um three subdivisions of text that are going to be really important for this presentation and for the encoding work. The biggest one is a verse, and it is all of the text that refers to one line of Virgil. It's in the light green box here, and it's the smallest numbered subdivision of text. The lemmas and the segs don't have numbers associated with them. This is a lemma, so it is the bit of text that refers to one specific um, word or set of words from Virgil. It can contain several segs. And finally, we have a seg. This is the smallest meaningful subdivision of text, and it is a bit of text of one type. Every time the type changes, we get a new seg. Did that help?
Yes, yes, I think so. I hope so. So please, for those who are in the audience, you can interrupt anytime for questions, because the text of Servius is quite complex, as you said at the beginning. So just to be sure.
Yeah, it is. It is a difficult text.
Yes, yes. And is a commentary about another text, another author. This is important. So the complex of the text of Servius is complex, and the complexity is also due to the fact that it is about another author, a commentary about Virgil. So, okay, thank you, Katie.
All right, I will move on to the next thing. If I can share my screen. Okay, so this next little bit of the presentation is going to cover my previous work in automating the encoding of simpler texts. And I want to do this so that we can kind of go through what it means to automate that encoding, what the like high level inputs and outputs and structure of one of those scripts are before we start throwing in the like added complexity of Servius. So this is what automation means. We want to go from the traditional printed critical edition that you're used to seeing over here on the left to an XML edition of the same text on the right. This is the example we had earlier. It's Caesar's Bellum Alexandrinum. And again, you've got your main text up at the top, your critical apparatus on the bottom here. By contrast, over here, the critical apparatus entries are in the text near the text that they refer to. So the reason we need to automate this is because this process is incredibly tedious. In a perfect world, everyone would just love hand typing their XML. They'd all publish their editions in, perfect validated XML. Unfortunately, we've yet to find any editors who want to do that. And so I am using my computer science background to automate the process to make it so that even editors who aren't super familiar with XML can publish XML editions pretty easily. So let's dive in a little more to how that process works. The main consideration is that DLL automation is as easy for editors to use as possible. It's got two input files, a plain text, so .txt version of the editor's text, and a spreadsheet or CSV version of the critical apparatus. Both of these inputs, especially the spreadsheet, are designed to mirror the format of a printed critical edition as much as possible, so that it's really, really easy for editors to produce them, and it's as similar as possible to what they're used to doing in their work. Once we've got those inputs, the algorithm for simple texts like Caesar is fairly straightforward. Using the sentence numbers as delimiters, we go through the text and wrap each sentence in a tag. We do the same thing with paragraphs. Internally, we represent the text as a big string, as a really long string of characters, and we use find and replace operations. once the main text is encoded, we then start processing the CSV, so the spreadsheet, row by row, still using find and replace operations on strings to build the tags and then insert them into the main text. One cool thing about these scripts is that they self-validate as they go. Right now, they don't validate against the TEI or LDLT standards, but they do check XML for well-formedness. So like, do you have all your angle brackets matching? Before they insert it into the main text. So you're guaranteed to never produce an XML document that is not well formed and therefore won't parse, which is really useful. So I'm going to show a quick demo of one of the earlier automation scripts running, and you can see how fast it is basically in real time. This version is actually slowed down for demo purposes. If I took out the slowing down and all the print statements, it would go a lot faster. So I'm going to run the demo script. Down here, you can see we're starting by processing the main text, the paragraphs, the sentences, the editorial markup, so stuff like those angle brackets, those editorial additions, lacunae, editorial deletions. Now we're adding on a TEI header and footer. We're writing that out to a new XML file. And then we're going to start on the critical apparatus. And so we go through the entries one by one. We print them. We just go through, and if it can't find a lemma or it produces invalid XML, then it'll put an error message over here. And this is our new XML. This green square means that it is TEI validated, and you can see we've got our paragraph numbers here, sentence numbers, some critical apparatus entries in the right places. Yeah, and this did in about a minute and a half what would take a person, based on my mentor, like typing it out by hand, probably 4 or 5 hours to do. So we're looking at a time reduction of about a factor of 400 or 40,000%. And that's pretty cool and pretty significant and makes it a lot easier for people to produce their editions. So I'll stop again and see if anybody has any questions. And if not, I'll keep going on to the Servius stuff.
Well, maybe a note. So you mentioned very important things. Well, of course, this is cool because, yes, we can produce an XML file very, very fast. But the important thing, as you said, so look at the structure of an edition. Okay, in this case is Caesar, if I'm correct. So, and our editions, this is based on a printed edition, they have a structure. So Katie worked on the structure of this edition, and then she could produce this script for automatically generate an XML where you still represent this structure, so paragraphs, and then the critical apparatus. In this case, as you said before, usually in printed editions, we have the critical apparatus at the bottom of the page. In this case, we can visualize in the XML file variants and the critical apparatus within the text. So this is the difference, but we still preserve the model of traditional critical editions. And then, as you said, so in this case, we have well-formed XML files. Then we will see later TI, which is another thing, and then we can validate that. So I think this is important in general because, of course, for classicists, this is important. But if you are not a classicist and you are involved in a project like this, the Digital Latin Library, this is important. Understanding, I think, the structure and the layout of printed editions, because this is the goal now. So to transform, to convert printed editions into XML files. I mentioned in this, Katie, because in Leipzig we have courses in digital philology, and so we always work also with students, not in classics, but focusing on this aspect, understanding the structure of our editions, which is fundamental then for generating scripts like the one you showed before. So yeah.
All right, so I think are we good to move on to the Servius stuff?
Yeah. One thing, Katie, when you start screen sharing, can you hide the bar, the Google Hangout bar? There is a bar. When you start screen sharing, you should see your screen, a white bar, and then you can click on hide so we don't see the Google.
Okay, I will hide it.
Thank you.
Okay, so now we're going to talk about automating the creation of a digital edition of Servius. And before we do that, you're going to get a 1-minute crash course in object-oriented programming. So a class is a user-defined data type that has fields, so internal data that it contains, and methods, which are operations that it can do to its data. An object is one specific instance of a class. For example, classicist is a class, and you are an object of class classicist. Objects know things about themselves and can do things to themselves. And what this means is that a programmer using a class doesn't need to understand its internal structure or how its methods work. They just need to know what's called its public API, so its application programming interface. I chose to represent small pieces of text using the servthing class that I developed in Python. This is kind of where my research became separate from just working for the Digital Latin Library, because using this much object orientation in an automated encoding process was pretty new and pretty significant and required me to do a fair amount of reading on computer science stuff. So let's kind of learn how object-oriented programming helps us encode Servius. We're back here again. You remember the verses, the lemmas, and the segs. Segs are what I represent with the servthing class. It's the smallest meaningful subdivision of the text. And the reason I decided to use a class here is because I needed a persistent data structure for associating the type of a servthing with the text inside of it. And I get the types from parsing the plain text edition and looking at where the pipe characters are and whether there's, text after the second pipe character and stuff. But once I've done that parsing, it's important to persistently associate it with the text. And that's really what a class does for us. It becomes especially important in cases like this. This is what I call the line 547 problem. Creatively named because the problem occurs on line 547. So what this looks like is that we have a parallel section followed by an outdis section. But that's not really true. What it actually is that this text, this wetabatur, belongs with this text, the quostam wetitis, etc. But because of the limitations of a print edition, it's typographically separated, even though semantically it belongs together. And so using a digital edition allows us to put back together that text that is typographically separated but semantically should be together. And the way we approach this is once we start encoding this section of Servius, we split it on line breaks, and we assume that each section with a line break between it is a new section. And then we find the type of the section. So here on the first bit, it would be both or same. Then we go to the next section. And if the type is the same, or if it's a parallel section immediately followed by a Servius or Servius Auctus section, we add the text to the previous seg tag. Otherwise, we make a new seg tag. And this adding the text, we use the add text method of the servthing class. And what that does for us is it allows the class to handle remembering the type, remembering where exactly in the XML this inserted text needs to go. The programmer just says, servthing.add text, and the class does the really low level type dependent processing. This is really cool because it makes it a lot easier. It makes it faster for experienced programmers, and it also makes it a lot more learnable for less experienced programmers. So I'm going to back up a slide and talk a little bit about, on a larger scale, how we encode Servius. So I mentioned when we were doing the Caesar, we wrapped all of the sentences and then all of the paragraphs. But here that doesn't really make sense because the internal structure of a verse, for example, the light green box, is really variable. It could have a ton of lemmas, it could have only one lemma. And so instead of wrapping all of the verses and then coming back and wrapping all of the lemmas and so on and so forth, we use a nested loop structure. So for each verse, as we come across it, we go in and we go in and start looking for lemmas. And for each lemma, as we find it, we then do this process with splitting up the text on the line breaks and making new serve things. And yeah, this nested loop structure makes the script a lot more flexible in processing a really complicated and variable text that doesn't have a really predictable internal structure. The nested loop structure is also useful because in Caesar, the smallest meaningful subdivision of text is numbered. In Servius, it's not. Verses are the smallest numbered subdivision, but the blue one, the serve things, are the smallest meaningful subdivision. And so when we talk about the critical apparatus, we'll talk more about the decisions that we made in why we chose not to impose numbering on the smaller subdivisions of text. So once we've got the base text of Servius encoded, how do we encode the critical apparatus? Well, generating the app tags from the spreadsheet is substantially similar between Servius and any other text, so we're not going to focus on it too much. The main difference is inserting the generated app tags into the main text. As I mentioned, for other texts like Caesar, the numbering specified for the spreadsheet corresponds to the smallest meaningful subdivision of the text, which is also usually the canonical citation scheme that most editions use. For Servius, we've got two subdivisions, the lemmas and the serve things, that are smaller than the smallest numbered subdivision. So we're left with the problem of finding where to put the app tag. The computer scientist in me initially said, well, just require them to number more things. It's not that hard. But I realized this wasn't going to work because our main concern here is usability. And we want to keep it predictably similar to a printed critical edition. So if we require additional numbering that's not in the usual citation scheme for a printed critical edition, then we're going to make it a lot harder for our editors. And so we chose not to do that, and instead we put the burden of finding where to put the app tags on the programmer. So currently what we're doing is we're searching for each lemma from the beginning of the matching number div. The time complexity, well, let me back up and tell you what time complexity is. When computer scientists talk about how long things take, they describe it in terms of theoretical complexity. And that complexity is the relationship between the size of the input that we call in is in November, and the processing time. And it's some sort of mathematical ratio. So generally in computer science, a linear time complexity, so time equals some constant times in, is really, really good. There are a lot of problems out there that linear solutions just don't exist. And there are a lot more problems that they exist, but nobody's implemented one yet. So linear time is really, really fast. And the time complexity of searching for the lemma from the beginning of the div is linear in the length of the div, and it takes on average in over 2 time. So that's pretty good. I'm working on a runtime optimization that will reduce the time to find the lemma to almost constant. And so a runtime optimization doesn't reduce the theoretical complexity, but it does reduce the time it's likely to take in practice. And so especially as we start processing like entire books of Servius as opposed to just like demo size, demo size and test size portions, that optimization will come in really handy. So I'm going to go ahead and show a demo of the Servius script now. I'm going to try and show you the right demo. All right, so we're encoding the divs here. This is where we do the main text. We put in the header and footer. And yeah, you can see that's how fast it goes without waiting in between the critical apparatus processing. So you can see we just went through all of them, made the tags, inserted them into the text. And now coming over here, this is our finished Servius. There's lots of cool stuff here. So you've got your divs that represent verses. These ABs, that stands for anonymous block. That represents a lemma. And then we've got those segs we talked about that represent one serve thing worth of text. That seg ends down here. And then let me find a choice to show you. Somewhere in here, I don't see it right now, there's also a choice tag that has for a parallel section that has the one set of Servius text and one set of Autis text. So that's pretty much how the Servius script works. This red box up here means there are still problems in the text, and I'll talk about that a little bit more in the future work section. But basically, my mentor and I are still deciding how we want to cite external resources that are mentioned in Servius or by a modern editor of Servius, and so we haven't come up with exactly the right way to do that yet. All right. So before I do the future work bit, I'll
And one thing, Kate, is that the XML file you were showing in this case is
how do I unshare my screen
yeah.
here?
Okay, thank you. It is a TI XML file.
Okay, there we go.
So, Katie, the XML file that you have just generated with your script is in this case is a TI XML file. That's correct, and this is the reason why you have this problem.
I don't think I heard all of your question.
Okay, sorry. So the XML file you were showing in your last slide is a TI XML file.
Correct.
Yeah, no, I'm mentioning this for our audience because before when you were showing, and we have people also who follow us, they are not well expert in TI. So before with Caesar, we could see a well-formed XML file, which is one thing, and now for this example with Servius, Katie was showing a TI XML file. So TI is the text encoding initiative, where we have specific guidelines, and so we also have a schema, so we have to validate our file. So this is the reason for the problem, for example, concerning the ref. In this case, for including references to other sources. I'm mentioning this, Katie, because we have a mixed audience and also people who don't know about the TI XML.
Okay.
So to clarify.
Yeah, thank you. So actually both, maybe I didn't cover this super clearly, but both Caesar and Servius are encoded according to the same guidelines. So they're both the LDLT guidelines, which is a subset of the TEI. The Servius doesn't validate yet and gets the red square because the DLL higher ups are still deciding how to do those citations. So that's where they're at right now.
Okay, excellent. Thank you for this.
All right, so I'll finish up, talk a little bit about my future work and some cool stuff that is hopefully coming up soon. Okay, so my future goals for Servius are, I spent a fair amount of time on semantically encoding these references and the text reuse that we were talking about. That's why the document isn't validating yet. And then I did some cool stuff with automatically inserting CTS URNs to Virgil. And those do work. Inserting URNs to texts that are not Virgil, I was starting to work on it and like cross-referencing them to the bibliography of the TEI edition. And then my mentor decided that because Servius is such an edge case, that's probably not worth the time. And so we're probably just going to ask the editor to hand correct those, like, I think it's probably on the order of 50 instances in about per book of Servius, because Servius is specific and is an edge case. Moving on from Servius, my big goal is to start applying this concept of object-oriented text representation to other texts and other uses. I'm going to start simple, so start with prose like Caesar, and develop plain text to object representation and TEI XML to object representation scripts. And the ultimate goal of that is writing Parapythea, a Python library that will generate object representation of text and give programmers and digital humanists a easier and more unified interface for interacting with TEI text. It'll allow editors to avoid really tedious error-prone tasks like type checking and XML syntax validation, because classes can do all of that for them. Ultimately, my goal is to give humanities scholars a more accessible interface for interacting programmatically with text, specifically in use cases like text processing, like natural language processing, like using the classical languages toolkit, because we can abstract away having to deal with XPath and XML syntax and just let users interact with text like it's a native Python object that they're used to using. And it'll make it easier to develop and use NLP tools like the CLTK. I just finished writing the proposal for Parapythea, and then my mentor was pretty okay with it, so I think I'm going to start working on that in the fall, and maybe by this time next year, there will be a release of Parapythea out. Also credit to my mentor for the name, because we needed something that had both Pi and TEI in it. Yeah, so these are some links that I'll put up before we move into questions and discussion. This link is where all the scripts are. This is where the documentation for all of the scripts except Servius is. I'm still working on the Servius one. I forgot to take this link out. It goes to an older version of these slides. So please use the link on the Sunoikisis GitHub page. And then here's my GitHub and my email if you want to talk to me or have like more questions about the Servius stuff and DLL. And so with that, I will open it up to the group for discussion.
Okay, so Katie, thank you very much. It was great. And two things about, so you mentioned the CLTK. I have to say one word. So the CLTK is the classical language toolkit. So for applying NLP resources to classical languages, I'm saying that for our students who are not classicists. And well, before you also mentioned CTS URNs, I don't know if you want to briefly say what they are, but maybe this is about the data citation anyway. If I understand, you will include maybe later, not now. If I understood, you briefly mentioned that. Katie, for CTS URNs, you don't want to include them?
I don't think I caught all of your question again. I'm sorry.
Okay, sorry, no. Maybe the audio is not good. So, well, the first thing about CLTK, but then you mentioned CTS URNs.
Yes.
And so you don't want to include them? This is not what I didn't understand exactly.
Okay, good question. Dr. Husky does want to include them, but he decided that it's not worth the time to develop a feature in the script that cross-references with the edition's bibliography and inserts them automatically. He decided it would be more effective to have either the editor or one of the other DLL students insert them by hand, since it's a pretty difficult problem and a fairly small number of instances.
Okay, so thank you for this. Again, for our audience, so CTS URNs are, CTS means canonical text services, and this is a protocol for providing unique identifiers for, well, in this case, for text, for classical text. And here, so the problem, and Katie is mentioning this as part of the workflow, because the Digital Latin Library is a new project, so they have been working a lot. So as you can see, they are deciding what they can do. And of course, Katie, you can't do everything. And as I understand, so the idea is, if I understand, is to include CTS URNs when you have references to other sources in your text. And of course, the decision is if you want to include them automatically with your script or not. And okay, here we have complexities because CTURNs can be complex, and then it depends on the kind of editions you use. So I understand the problem. So this is an interesting point. So we can't today really talk about CTS URNs, but given that you mentioned them, what I can say now for our audience is that this is about, well, data citation in some way, and CTS is this specific protocol for providing URNs for unique, stable identifiers for our sources, in this case in Greek and Latin. And so this point is interesting because, as you can see, Kate is discussing with her mentor, also, who is also the director of the project, the Digital Latin Library, how to go on. So thank you for this clarification, Katie. And okay, so well, yes, in the chat we have on Google Hangout we have a chat. So Anise is a professor of Greek. She's from Araraquara in Brazil, Unesp, and this is for you, Katie. So just to contextualize this, so Anise has been following a lot our work, and she's working with us in our community. I don't know if you have questions. We have computer scientists in the Hangout. So here really you can see a young student and researcher combining these backgrounds, because Katie has two backgrounds in computer science and the humanities, so she can manage both. And I think that this presentation was really a great example, especially for a new generation of students, what you can do. Of course, you need both backgrounds, and I know that Katie has been working very, very hard for getting this, and she's doing a great job. So if there are any questions, please don't be shy. I understand that the presentation was very, very clear, but of course the topic is difficult because especially for the editions here, we have complex editions, as you can see. And the Digital Latin Library is a new project, not only for providing the reconstructed text of Latin sources, but the complete critical edition, as you can see, with the critical apparatus, which is one of the big challenges we have now in digital philology and in the digital humanities. So to transform printed editions into machine-readable editions in some way, and then to produce newborn editions. And the good thing is also that you can access data produced by Katie. So you have your GitHub repositories, so you can see what Katie has been doing. I don't know if there are questions. I'm also checking on YouTube because we also have okay, we have other comments on YouTube about your wonderful presentation. So really, and yeah. Okay, and so now, I'm checking also on your class outline, and we have, okay, as a reading, so we also have, yes, of course, you have more about the Digital Latin Library, and yes, we have also this page by Hugh Cales for modeling Servius for the Digital Latin Library. I think this is an interesting discussion about, because here we have a lot of work behind. Servius is not easy, so.
Yeah, so that post by Dr. Kalis, it's a sort of a recap of the meeting where Dr. Kalis and my mentor and a couple of other people, including Tom Elliott, who is the Epidoc guy, that's when they decided on the data model for Servius. And then my mentor said, like, hey, see if you can automatically generate this. And I was like, I'll see if I can automatically generate it. And we made it work.
Okay, that's cool. So for our audience, so please read this blog post, which is very interesting also because here we have digital philologists and humanists. Katie mentioned Hugh Cales and Tom Elliott, so people with really a lot of experience in digital philology and the digital humanities. And as you can see, so they discuss the structure and the model, and then Katie was able to generate these scripts for automatize the process. So really great work, I have to say, because it's not easy. But this post is important because you can really read carefully about the model for Servius, okay? So you can have more information, and then you can see the work done by Katie. Okay, so I mentioned this again for our remote students and people following us. So this post is important. Thank you, Katie, for mentioning this. Okay, so I don't know if I don't think we have questions as for now. So your presentation was very clear, but I think that now our audience has to read the post and to go back to your script. And we have, okay, excellent. We also already have the link to your slides, so everyone can access your slides and you can go back through the presentation. So Katie, thank you very much. And I'm happy because this is basically the first session with an undergraduate student presenting alone her work. So this is great, and this is the goal of Sunoikisis, involving young researchers. And as you can see, this is really active research. So Katie is contributing to a big project, a cool project on the Digital Latin Library. And so she's really producing new research. And this is also partly the result of the institute we had, in the sense that, of course, this is your work, Katie, but last year I know you came to Tufts, and well, we could learn a lot from your work, and I hope you could get also from our institute, especially concerning annotations. But I'm happy because this is the result of many activities we have in our Sunoikisis community. Okay, so Katie, I think that's it for today. And so
Yeah.
thank you very much for your great...
Thank you for giving me the opportunity to be here, and audience and YouTube people. My email is in the slides if you have any questions or are interested in learning more.
Okay,
Have a
excellent.
great day, everyone.
Thank you. This is the spirit of Sunoikisis. So thank you, Katie. Goodbye, and well, good afternoon, I have to say, and good night for other people in other time zones. So see you and bye. Bye-bye.
See you later.